as a homework, a work for you to do the calculation of three sides. So anyone can show me the result? Neither. You forgot the book. 他真的 do or don't do, not do. You did it. Salam, are you finished? Okay, everyone listen to me. If we do the three sides, only one side, three sides, very complexity of three sides, we can follow in this case. When in the three sides, so what's the first step? First step. Okay, look, I will image. For three sides, why is it complicated? Why is it different to the two sides? I almost use one class to explain you. Did you forgot? Why is it complicated? With wedding three sides. Why? Neither. Why? The complicated for this case and this case. Why expensive? I was asking you. More expensive, yes. So, but we talk about this calculation simply. Okay. Now you are very right, very rich. You can work in all the things. So why is it complicated? We can discuss about this one. The weightings, the force applied here, right? And then the force applied bearing directly by these two sides. This is case A. The case B, widening this here, a force extension this one, right? A force applying here. The B, the force always bearing in this surface, right? So, but the case C. So now the force N, right? This is N1. This is N, right? So what's the force of this one is what? Do you know that?
Yeah, force will be shared.
The shared. So this is N1, N2, N3.
Right.
So N3 is what? N1 maybe N2 equal to N2, right? But we still unknown the N3.
Yeah.
So how to do this design with three unknown? Now we solve this problem. Placing. Do you understand? Kalenta. George is not here. Okay. Is George name?
Yes.
Okay, can I clear this one? So we can see it back, come back. So now we talk about the three edges. First things we separate the bearings. This is called M1. This is called N decrease N1. N decrease N1. Right? So one thing, if you solve, you can calculate. So how to calculate the N1? How to calculate the N1? Everyone knows that simple rulers that F smaller FW, right? Zhang Keli, what's this? This is loadings applied in the surface, right? To the surface. We have M over the areas, right? Is right? Eliza, can you understand?
Yeah.
And now, so how to calculate the M1? If we do the design with both, with just M1 is agree this ruler, right? Agree this ruler. So M1 smaller should be smaller than this 1 point the A, right? Right? M1 should be agree this ruler. It's a rule. M1, so M1 should be equal to FW point the A, right? But M1 is the end connection. It should be point beta T. Do you remember the beta T? You can see here. Because the force in the hand is complicated. Remember that? Lisa, remember that? So we should point the beta. And what? Right? This case. Now we can expand this equation. Beta F point the FW point the HE means the Fourier in this surface point the lines. How many lines of this one? Okay. Now we can calculate the M1. Just the end widening is safety. Right? Now we can calculate the M1. According to the equation, we have now this one equal to 1.22, right? And this one, for the case, we equal to 160, right? HE, we have the side, right? You remember, for example, it is 8. The LW, we also have the side, right? So for example, it is 400 decrease 2 times 8. This is equal to 0.7.8. Right? Now we can calculate the M1. Can you understand?
Yeah.
Totally don't understand. From where? From here?
No, this one.
From here?
No, down.
This one.
Yeah. In one.
You means the beta F? Don't know. Okay. Anyone can explain the beta F is what? Yes. Aaron. The beta F is what? 都不明白，很好。But you all know. I now explain the reasons. I like that. Normally, it's complicated. We can see that the force, the very force, no, you can see here. You can see here. for this welding paste, right? Welding paste, normally failure is in this surface, right? Failure in this surface, so we have this is HF, the welding length. So we can get the failures, so failures, the H length equal to 0.8 HF. This one you can understand, right? And we found along this side, it is LW decrease 2 times HF. Okay, now we found the surface. But for the force, after driving, we can get the shearing force is equal to m over the 2 times over the areas of the paste. But the hand, when the welding is perpendicular to the welding paste, it is much different because you can see here, for the hand, for the side of paste, normally the stress is even uneven, but it is much that's almost the same, right? Exactly the hand. But for the hand, it is complicated. So to simplify that, we need a point, a parameter, coefficient to modify the force. Okay, then can compare to the result. So they will have a parameter beta f. Clear? Then we have beta f. So we can calculate the end part. Do you but you should very carefully. If you forgot the beta f, you will be make a mistake. Okay. For the end wording. Clear? Now we calculate the N1. For example, N1 equal to 100 kilonewtons. For example. So these two sides will be N decrease N1, right? Over the areas should be smaller than Fw, right? So now this one is safety, this one is safety. Now we can check, finish the checking. Is safety. Clear? If you don't clear, you can check the PPTs. So if you're clear, we continue to do a design like this case, Before on the job, we should know one thing. You all remember these tables? When the windings in this line, for the angle steel is different for the plant, right? Angle steel, not is widely used for the footing, for the corners of the other beams. Widely used the angle steel, right? But the angle steel winding in the bed and the tip, the force is different. So the force is different. For the angle steel. If I am applying here, there will be produce a force N1 and N2, right? So N1 is right?
No.
No. So the N1 equal to what times N2 equal to what? Equal to what?
N1 0.78.
So now after we have a table to describe different situations of the case of this welding case. If for the equal leg angle steel, they want 0.7, 0.3. It is with long different unequal leg angles. If welding the short leg together, the K1, this part the K1 equal to 0.7, and this one equal to 0.22, 25, and also it's different. So we can get, for example, this is equal. This is equal leg. We widen this here and here, here and here. It will be equal to N1 equal to 0.7 N, N2 equal to 0.3 N, right? Right? So for the case now we can see that for the widening 3 edge of the wide, we firstly to calculate, normally this one also widens here, three sides. So N1 will be calculated by this case, and then calculate this N1, then we can check this N2 and N3 is safety or not safety. Right? So see this case, how to calculation. Can you try this one? So you can see here, I explain the case. Now a force wording like this one, right? The N equal to what? 1170 kilonewtons. The HF equal to 8 millimeters, right? Already give you. And the length back weighting, this lies LW equal to 400 millimeters. This one equal to 25 millimeters. 250 millimeters. And L size is what? Okay. L size we have get it because the L size means the weighting this part, right? So the L size is the size of the angle steel, right? This angle steel, the size of the angle steel is 2 angle steel with 140 point there, with thickness. So this LW3 equal to 150. Do you understand? Okay. Now we have everything. You can do it. You can do it. And this method, we firstly to calculate this one. First step. S equal to what? Can do it? Do you have a paper? Try to do this. If you don't have a paper, you can do that preparation in the blackboard. Salon, you know how to do this one. For you, it's too simple. Morris, for you, it's too simple. Lisa, for you, it's too simple. Come here. Come here. Okay, wait, Zhang Lee.
Yes, wait, Zhang
Do you need my help? Right now, you need my help. You still give you 5 minutes. LW here is the size. Each leg is equal to 140 millimeters. So means this is kind of all the size, right? And so LW, this one equal to 140.
So since that we
Decrease 2 times the HL.
okay. So let's say so we go N3, right? So N3 here is also 140 minus
Yes.
the
HL could be taken to you.
Yeah. So wait, this one for this for that side. So N1 what? Like N1 that one that's what we're talking about. The side that side.
Yes.
It's 400. You have to use 400. But here what they got was
Yes.
if we're trying to find N1. This N1 that side, then this that's there. For LW it's 400.
Yes. I thought this one is wrong.
This one is wrong. This
There
one
is check. You can, I will tell you, but it almost is right. You have the right length, right? You have right HE, you have right F, you have right beta, but you still wrong. I will explain you. Anyone who finish?
You mean he's doing?
What is? Okay, you have right beta, you have right F, you have right effective side, you have right loss, but you still wrong. Right, everything is right, but everyone should be very, very careful. But I think every group will be finished. Right? Very good. Okay, stay here. I think, guys, you can think from Okay, you are right.
I talked to him.
You told him,
Yeah.
Elisa, come here. Explain for us. Come here.
You just go.
No, it's your. Okay, you can see here. Everyone, this is right 122, right? Well, it's right. This one, HE equal to 8 millimeters, right?
multiplied by
Multiply 0.7.
which is 5.2.
Well, we should decrease the meters. Decrease 1/3. Okay. Never mind this. I write the units for here. This is a kilonewton per.
Oh,
We-
yeah.
Millimeters square. I'll write the MPa. This is meters. This is millimeters, right? And this one, right? But you have how many lengths of this it will have? For example, this case for only winding this part, you can find they have 2 plates. So you have 2.2. Remember, a lot of students didn't winding the 2. Okay. After calculations, we can get this is 306
But you didn't minus 2.8.
kilonewtons.
think minus 2.8.
Minus 2 point what? Oh. My problem. 2 times
8.
8.
Right.
Very good, very good. Kilonewtons. Kilonewtons per millimeter square. Okay, we get these values. Now, the second step is to calculate what? So now we calculate the N3 equal to we can using these equations to get N1 and N2, right? N1 and N2. So N1 equal to what? N2 equal to what? Elisa, this you can do this one. N1. Come here. N1. Can you don't take the papers?
I'm not master.
Okay. Remember, you can focus on this one. This case.
And 1 is 2.2.
Yeah.
Relax. You just only put this one is right. 0.7 point to the end.
Yeah.
That's why
0.7 is K.
Yes. Point.
I don't know.
0.7 and point. No, this is he writes it too much.
Yeah, and it's
He writes it too much. Decrease because decrease three and this is how why you why you separate two? Totally correct.
It's just like that.
Yes, this is how school. No, put it in here. That's right. So this is your answer, not my answer. Not correct my answer.
so it might be wrong.
Might be wrong.
Wait, why did you not mention?
Okay, it's enough. So this is your answer, not my answer, not a correct one. Everyone to check it, this is right or wrong.
I think it's wrong.
Why? You can say it's right. You can maybe it's right. 1100 and n decrease the n3, right? We can get the total force of this one, and then point to the 0.7 equal to this one. It's right? Really? Who think it is wrong?
Okay. I think might be right.
So I plot a figure in here.
No, it's wrong.
Why?
Suppose it's 604.
What is K?
0.7.
K is 1.
So anyone can calculate to check by yourself why it is right.
Divided by 2, which is 1.
Yeah, can you try this? It's correct. It's correct.
It's correct or not correct?
Right. I can try to explain. Yeah.
Sure.
Can you try to explain?
There's the diagram. That is K.
0.7.
Why is it giving me 6?
666. K is correct.
Because I'm just trying to do exactly that. 666 is always not coming.
It's coming now.
Yeah, 1. Try using the calculator. Calculator check. Yeah. But this one, look at this one. It's 306.
1, 1.
864. That one, the answer, that answer is wrong. You must bring that one.
So if this is right, we can calculate the 0.7.
And now, and 864 multiplied by 0.7 is giving us 604. 666, I don't know. What's coming from.
Yeah, it's giving 666.
How?
Yeah. Giving 666.
Something like that.
Check. Let me show you.
But it's going to say even this one, it's wrong.
So which one is right?
666.
No, it's not 666. It's not 666.
No, it's an answer for you. You can discuss.
Don't worry.
It's simple.
This is what we're using.
No. Why now I question why the N3 should over 2.
Because we have because N3.
Okay.
Because
You're forgetting N1 and N2 are not equal. N1 and N2 are not equal. It's 0.7 and 0.3. Not 0.5, 0.5. No. It's 0.7 and 0. That's why he's saying y over 2. Because over 2 means that
we're getting first.
yeah,
Listen. We get first. We half of. We divide by 2 first.
Why?
Then we share. When the answer we're going to get. Let's say it's 2. Let's say it's 4. That's when we divide from the ratio.
Right.
You say this is 0, right?
Okay, where is that coming from?
You get what I'm saying. Yeah. Then you divide according to the ratios you get this.
But again, you're already given ratios which are telling you they are not equal. What should you divide by 2, trying to make them equal, then in the end still make them not equal?
What times?
That's what I just said. Look, N3 divided by 2, why? Why?
I just explained again.
Because there's N1 and N2. Because there are 2. I'm telling you no. Because you're already given N1. It's carrying the numbers.
You're overthinking, guy.
Okay.
Oh wait, N1. What did you find for N1? What value did you find?
That's what we're finding.
What about N2?